Good morning, guys and girls. Today we're going to talk about which dehumidifiers to use on jobs to your advantage. I know we've talked about dehumidification before, but I don't know that we have actually, went through a comparison to show the advantages and disadvantages of stuff like that. So let's talk about that a little bit and go from there. As you all know, there are several different dehumidifiers that you can use, and so let's talk about those and talk about the difference, advantages and disadvantages, and maybe some stuff you hadn't thought about. We want to talk about several things today. One of them is the variables and losses and what are variable different things on a loss that would choose you to pull a different tool out of your toolbox. As you know, you'll have several choices in dehumidifiers and air movers and this, that, and the other as you go through. And it's important to use the right tool that you've got to make the job easier for you and to make the job maybe cheaper if you're having to bid the job, make the job easier to do. So there's several different reasons that you would decide which kind of dehumidifier to use and what type of stuff to use on your job. So we're going to talk about how to determine which dehumidifier to use and which dehumidification process and which system. And then everything's always got a little bit of a twist to it to where we may talk about using one type of deskant on one type of job, but you may run into a situation where that won't work. So you need to know about all of them that you've got access to so you can get it done. So we're going to talk about the different types of dehumidifications, and we're going to talk about the pros and cons on each type of dehumidification. We're going to talk about your fully loaded cost when it comes to dehumidification and doing the job. Fully loaded cost meaning that we try to include everything there, which would include the deskant, the cables, the generator, the fuel to go in it, transportation to get it to and from the job site, your transportation at the job site, while you're at the job site working, your labor, and your different stuff like that. So we want to talk about all of those kind of things while we're going through this. Again, talk about the pros and cons of different types of deskants. They being one of the larger and easier types of dehumidification to use. There's propane deskants, there's electric deskants, there's diesel deskants. So you got several different fuel choices that you can choose from. We want to talk about the pros and cons of each one of those different fuel sources. How do you determine which dehumidification to use? You got LGRs, you got deskants, you got heat drying, you got DXDH, and then you want to talk about the efficiency of which system that you're going to use. Because if you get in a bid process where you're bidding or trying to get the job, and maybe somebody else is trying to get it, and you have to give somebody a price, then that could change your decision on using a more efficient deskant. Some of the variables will include building blueprints. What's the footprint? Maybe better word than blueprint. What's the footprint of the building? Example, in a hotel, deskants may or may not be your best choice. If you've got 60 individual rooms to do, you may want to use 60 LGRs to do the individual rooms. Do you have HVAC in each room? Your HVAC makes a good dehumidifier. It actually helps you out with the process and helps you control your temperature when you're looking into a room. Again, hotel rooms are fairly easy. They're one of your easier ones. You generally got different circuits and plugs for each room, so you got plenty of electricity to plug up a few air movers and a few dehumidifiers, and a lot of times can do that without power distribution, except possibly down the hallways. A lot of times the hallways don't have but a couple of plugs, primarily designed to run vacuum cleaners for the housekeeping service, and they're usually on the same circuit. So you start plugging a couple of DUs into the circuits in the hallway, you may blow a circuit. So you may have to have a limited amount of power distribution to be able to get through that. The size of your building is going to make a difference. Um, if you've got a huge building, then you have to think you may or may not have enough electricity in the building to run the entire process. We all know that most of your dehumidifiers are carrying about 7.5 amps of draw each. So, if you put 100 in there times 7.5 amps, that's 750 amps of power to pull, and your system in the hotel may not handle that. Um, you certainly don't want to set the hotel on fire by overburdening their system. So in that case, then you may have to go to alternative electrical sources, or maybe choose an alternative dehumidifier where you don't have to have so much power to run it. Uh, so look at the size of your building, of the affected area of the building, the wet area, if that's what you want to call it. Another thing you'll want to look at is the difficult building materials to dry. Gym floor is pretty difficult to dry. Uh, High ceilings make it more difficult to dry, where an LGR may not be as desirable. Uh, Plaster in a ceiling has varying degrees of difficulty, including not heating it too much, but getting enough heat on it to get the material in a plaster ceiling dry. We dried one in a bank in Fort Wayne, Indiana, and the gold trim on the plaster ceiling cost over $1 million just for the gold trim. So we certainly didn't want to start popping the coats off the plaster and watching it fall and hit the floor. So we had to get some experts in there to look at it and give us suggestions and figure out exactly what was the best variables to use on that for dehumidification. When to use an LGR, desiccant, heat drying, DXDH, and their efficiencies. Let's talk about LGRs a little bit. Low grain refrigerant, I think you all probably know what those are and what they dry. Again, they're really good for small rooms. They're good in a residential setting. Usually can put 2 to 3 in a house and get good dehumidification out of it, providing they're working okay. So LGRs make good residential and or small room dehumidifiers, but they may not make as good of a system for hotel lobbies and meeting rooms and ballrooms and stuff like that. You may want to switch gears and go to something else. Um, Desiccants, we generally look at that when you're looking at a building around 20,000 square feet of loss, of wet area, and or dense building materials. You can use a desiccant on something smaller than 20,000 square feet, but you may find yourself getting a little pushback from the consultants and adjusters on it. So, good rule of thumb is 20,000. Of course, if you're doing a gym floor and it's only 10,000, it's got dense building materials. It's got a lot of wood in it. The ceilings are really tall. And we all know we size these things efficiently by cubic feet of air to be exchanged, not necessarily square feet. For the purpose of today's meeting, we're going to give you just a thumbnail view and saying that you would start looking at a desiccant at somewhere around 20,000 square feet. Uh, no magic numbers. I've done some 100,000 square feet buildings with LGRs. I've done some 10,000 square foot buildings with desiccants. You just have to look at all your variables and pick out which one you want. Heat drying. Some people love it. Some people hate it. I like heat to use, especially when you're dealing with crawl spaces in hardwood. Uh, Heat will dry the dirt out in the crawl space pretty easily. In a normal house of 1,500 to 2,000 feet, you can use something like a 400 to 500,000 BTU heater, indirect fired heater, duct it into the crawl space, and it'll blow the dirt dry in a fairly quick method. If you're using that method for a crawl space, if you're putting in 500 CFM, be sure to be pulling out 500 or maybe just a touch more CFM, because you don't want to put a crawl space under positive pressure and send the contaminants that are normally found in a crawl space, the musky smells and odors and that kind of stuff, up into the living area of the house. So you need to keep that under neutral pressure at worst, and a little bit of negative pressure at best. But heat drying is really good for crawl spaces. It's really good for hardwood. It's good for plaster. You'll hear some critics out there that'll say if you dry hardwood too hot and too quick, you'll make it crack. I would encourage those critics to Google how they kill dry hardwood before they dry it and put it into the house, and then let them rethink their position. You cannot over dry hardwood with a desiccant dehumidifier or an LGR. You're not going to get that much heat on it, and not going to get it done like that. So some people like to tin hardwood floors so they have less area to dry. It's fairly expensive, and I've found it may be just as expensive somewhere just to add another desiccant, but again, depends on your situation. A lot of consultants and adjusters like to see them tinted so you can uh, decrease your cubic footage into the area that you're trying to put heat into and not be trying to dry so much. Um, DXDH, it stands for direct expansion dehumidification. It's a big fancy word for a heater and an air conditioner. Big central unit like you'd see sitting on the roof at Walmart or Home Depot. The only difference that makes them a direct expansion dehumidifier is that we configure the switches and the safety switches and the on off buttons and all that so we can run all the air conditioner, or we can run all the heat, or we can run all of it at one time, both heat and air. You say, well, why would you want to do that? Well, when you're cooling air, an air conditioner is a great dehumidifier. It brings the water out, it causes it to form on the coils, and the water goes running across the parking lot. And it's a good dehumidifier, and it's extra large, so that helps you with that. When you turn heat on it, it heats those coils up and causes you to get extra evaporation out of it, or extra water removal. Uh, Also, a lot of times we have to run the air conditioner during the day, and then when it cools off at night, we have to run the heaters at night. So, particularly if you're using LGRs, as you know, you want your temperatures to stay between 60 and 90 degrees. 70 and 90 probably is more optimal to get good performance out of your LGR. So, if you're getting cold nights and you don't have heat in the building, you may have to run heat at night with the DXDH, and then if it gets warm in there and the temperature gets to 90, then you may have to cut the air conditioner on during the day to cool it back off, because your LGRs, one disadvantage, and we'll talk about this here in a minute, is that they will not work at temperatures when you get outside that temperature range. They simply quit functioning and become useless. LGR comparison. The pros of LGRs are small to medium size. Water losses are good to use. Uh, they're good on residential. They're good for surface drying and surfaces that have a low water content, on low moisture content. Uh, they're not the best tool probably for something that's extremely wet, such as a flood job that's where the water's been pretty deep. It will work. It's just a little bit slower. Um, if you have to have a concentrated area of drying, such as an office, doctor's office, maybe in some different rooms, even if you're running some other type of dehumidifier, they may be the tool of choice. They use less energy and can work in very low humidity conditions. However, as I've already said a couple of times, you cannot use them in low temperature or high heat. They have to stay within that range. Draining sites in commercial buildings are hard to find sometimes. You get a big big commercial building that don't have a lot of bathrooms in it, maybe just have the common bathroom down the hallway. Sometimes they're hard to drain, so you might have to get barrels and put barrels in there to collect your water. So sometimes that's a pain to get done when you need 30 barrels at once. Um, these larger dehumidifiers uh, use a lot of power. And once again, in commercial buildings, unlike residential, there's really not a code on how often you put a plug. They just sort of put them where they want to and wire them in. And so sometimes you will get a big office area that has a few plugs, but you'll find out they're designed to run computers and that you may not be able to get enough electricity to power those. So you may have to go with power distribution. If you're driving a building with no air conditioner, no elevator in it, they get awful heavy carrying up 10, 11, 12 flights of steps. But sometimes that's a tool of choice to do that with. You just have to manage your people and get them to carry them up the steps, and usually going one flight of stairs at a time, one half of a flight at a time with two people, and just starting them like a chain line to get them up there usually works better than anything else. Notice in this picture it says LGR 7,000. And 7,000 really don't mean much of anything. Probably should be a 700 pint, but keep in mind when you're sizing dehumidification with pints that that's at the optimal temperature of 90 degrees and the optimal relative humidity of 80. If you'll do the grains on 90 degrees at 80% relative humidity, you'll find that that's never happened on Earth. So, other than in a laboratory. So you're not going to get grains that high. So you're not going to get 700 pints out of that LGR that's showing there. So that's just sort of kind of a made up number they stick on there to make it look good. So just keep that in mind when you're sizing dehumidification equipment. DXDH comparisons. Again, direct expansion dehumidification. We can run air conditioner, we can run heat, or we can run everything at once. The heater banks, they usually have 2 to 4 in them. You can choose how much air you want to run. They all have the 20 ton, 25 tons will have 2 compressors for the air conditioner. You can choose how much air conditioner you want to run. And you just sort of get your meter out and get your notes out and figure out what you need inside your building to control the atmosphere and get it to your desired goal. And then you design the DXDH and turn it on like you need it to be. They're a good tool to use during extreme temperatures and climates, whether it be extreme hot or extreme cold, because once again, you can run either the heat or the air. If you look up the OSHA standards, which I do not have in this slide, the OSHA standards has extreme guidelines on working your people in PPE equipment in extreme heat, and they call extreme heat. They have different levels for 70, different levels for 80, and different levels for 90. So it's really hard to do a mold job when you got the inside of a building at those temperatures with no air conditioning to make any progress. So look up those OSHA laws on the extreme temperatures, and that's another thing that a DX comparison will help you on. They're more efficient than an LGR. They do squeeze a lot of water out. They're a larger unit than an LGR, so they are very efficient when you're doing that. You have less setup time on a DXDH unit than you would have on a whole bunch of LGRs that would match the size of those. You get more grain depression in the DXDH than you get out of LGRs. So you're going to get drier air coming out of the atmosphere. If you need to use LGRs in a building, a lot of people put deskants in and then LGRs. Well, once that temperature reaches 90 degrees, and those deskants will run it up there pretty quickly. Once it reaches 90 degrees, your LGR is not going to work. It's a useless piece of equipment. In fact, it's generating heat that's causing you to have more energy in the air and in the atmosphere, and thus causing further problems and causing them not to work even more. So if you're having to put LGRs in and it's going to be a warm day or a cold day, and that's where you use your DXDH in compatibility with your LGRs to keep your temperature at 70 to 90. They're very quiet. They're designed to run in houses and buildings and sit right outside the building, so you have very little noise on them. You got a quiet run generator hooked to it, and you won't have much noise with them at all. They're absolutely the best choice for climate control. Like we talked about a while ago, you can put heat on, you can put air conditioner on, you can just choose what you need to keep your building going at the temperatures you need it. You can have a thermostat wired into the building if you need to. If you're going to have something there a long time, a lot of people like to do that so they can set the thermostat. Great option for mold jobs. I talked to you about heat just a little bit when you're working in PPE. So if you got your people working in high heat and you're getting outside the OSHA mandated, not recommended, OSHA mandated guidelines, then you've got to keep those people cool. Or maybe warm. You just don't worry about warm too much in PPE because they're sweating enough in it to not worry about it, but you do have to keep them cool when the weather's hot. They are harder to use in occupied spaces than like residential or hotels or assisted living or doctor's offices. You have to run a tube down the hallway to push the DXDH air down there called lay flat tubing. So particularly if you need to put a dehumidification in each room of a facility, then you may very well need the LGRs to do that. If the temperature don't allow for LGRs, then you may have to engineer the DXDH to go into the existing air conditioning system or engineer the lay flat tubing to where you can keep the building at your desired temperature. A lot of times there's no space on sidewalks. New York City, Jersey City, Nashville, Tennessee, pretty much any city with narrow streets. And you get older buildings, which are more susceptible to water damage, but sometimes you have limited space. So when you're deciding which type of dehumidifiers to use, that's something that you need to keep in mind. Grain depression is better than LGR, but it's not as good as a desiccant on grain depression. But they do have that all-important temperature control capability to them. Talk about desiccants and the pros and cons on them a little bit. They're the very most powerful and probably the best tool to use during extreme temperature climates. They work during hot weather. They work during cold weather, although your building materials will not give off very much moisture if the wall surface, the floor surface is cold. The desiccant will put out anywhere from 118 degrees to 160 degrees, depending on which desiccant you're using. So they do help add heat, but you still got to get those surfaces warm for them to be able to evaporate moisture out of them. So sometimes even with the desiccant, you may have to add additional heat. Or some people may just put an additional desiccant in, but usually if you've got enough drying capacity, you probably would want to just add heat. You get more effective drying of dense materials, being like plaster, lightweight concrete and floors, any dense material that holds a lot of water. You have less setup time on a desiccant than you would a bunch of LGRs. You're setting up one piece of equipment with a generator instead of carrying 100 LGRs into a building, so makes your setup time less and things run a little bit quicker and maybe a little bit easier on you. You get more grain depression out of a desiccant if they're operating properly than you will any other type of dehumidification. You should get a 50% grain depression between the air coming into the intake and the air going back out the process air. So whatever your grains of moisture are inside the building, you should be cutting those in half. They're more cost effective to run, especially if you use some of the more hybrid diesel units that are available in some places on the market. A diesel unit runs on 220 volts of electricity, which means you can plug it into a lot of building boxes and a lot of building designs. You may need an electrician to do that. but it's cheaper than a generator, particularly if you're going to be running several days. And their fuel consumption is a whole lot less than the electric units. And You know how fuel cost is. A typical diesel unit will run about 2.6 gallons per hour. An electric unit, the generator will lead between 8 and 10 gallons an hour. So a good bit of difference in your fuel consumption on it. A little bit of the cons to it. They're harder to use in occupied spaces. Um, Residential being as well, harder to use. Hotels, assisted living, doctor's offices. It's hard to run that tube down through there and keep occupants in there. If they create too much heat, then you're going to have to add air conditioner to it. So if you're in a hotter climate, you may want to choose LGRs to do the drying, although it'd probably take a little bit of extra time to do that. Again, just like with the DXDH staging equipment, if you don't have a lot of sidewalk space or streets are narrow, or you've got some issues with city and stuff like that. If you live in Houston, you can't have any propane in the inner loop. If you live in New York, you can't have any propane on the island. So know your local state rules and laws. If you live in Miami Beach, you got to have a permit to have a generator anywhere in the city of Miami Beach. So if you don't, they'll write you tickets for running a generator without a permit. So just know your local laws and what they are and what you need to do, prepare, and the best time to figure that out is before you get the call. Let's talk a little about heat drying. You when you get heat drying, it's really good on crawl spaces. It's a really powerful tool in your toolbox to do with cold temperature climates because you're going to have heat to heat the material up anyway. It's more effective of drying dense materials when you can blow some heat on it directly or heat those materials up to so that you get a pressure differential, vapor pressure differential in the materials and force that moisture to come out of the material. There's some people don't like heat drying. They think that pushes the vapor pressure differential pushes the moisture back into the walls. So you just have to monitor your walls and monitor your vapor pressure differential and try to get your temperature up to where you need it and to just watch your drying and watch what you got going on with it. So I think I mentioned earlier they're great for dirt crawl spaces and stuff like that when you got to take those out. The cons are difficult to use during the summer. They get really hot. If you have an occupied building and you're trying to get that building temperature up to 110 to 140 degrees, somewhere like that, so you increase your vapor pressure differential, you can get a lot of moisture out. You have to vent this moisture out of the building. It's not like you just put a heater in there and heat it to 140 degrees and walk off. It'll look like your bathroom shower in the mornings if you do that. So you have to you have to take out what you're putting in. So you have to vent that heat out a window, out a door. You may have to put negative air machines in to pull that out. Use your gauges so you can tell your not only your pressure differentials, but tell how many CFM that you're blowing in and out of the building, so you can keep that as neutral as you can. But still, a really good tool to be able to use is in the heat drying. We hadn't really talked about conventional LGRs, but they really have no place in the drying industry. Those are good to put in your basement and try to control a little bit of humidity if you got damp moisture in your basement and do stuff like that, but they really have no place in the drying industry. They just simply won't get the grains low enough to be able to help you get anything dry on it. So hope it's been a little bit helpful today to go over some of the dehumidifications. Let's talk about the cost there for a minute that we've got and what your fully loaded cost is. So if you get somebody wanting a cost analysis or how much is this going to cost, one of the first costs you always think about is equipment. then you may or may not have to have generators to run it. Again, if you're using the hybrid diesel-fired generators, which just means their heat source is fired by diesel fuel instead of by electricity or propane, a lot of those run on 240 volt that you can hook up into most commercial buildings. And even if you don't, they run on a lot smaller generators. You don't have to worry about how big the generator is or how much fuel consumption you got there. You'll need electrical cables to hook up from the generator or the building over to the drying equipment. Of course, you're gonna need fuel and a way to haul the fuel. You got to bring it in on trailers. They're pretty big machines. Most of them are 12 to 14 foot long, 8 foot tall, and 4 to 6 foot wide. So just depending on how big a machine you get. You'll have to have hard ducting, also referred to in the industry a lot as rigid ducting. A lot of it's yellow, but you can get it in different colors. But that's duct that you hook up to suck the wet air out of the building, process it through the machine, and then blow the hot, dry air back into the building. The moisture dissipates through another exhaust that carries the hot, wet air out into the wild blue yonder and gets it where you don't have to fool with it anymore. Then you put lay flat ducting into the building and you run that tube throughout the building, usually up to 500 feet on a larger deskant, and then you cut holes in that to blow the hot, dry air throughout the building, so you get pretty good distribution on it. And then, of course, you'll have labor and delivery that you'll need to use to set up the equipment and get things running. And then, of course, you need to monitor your equipment all the time. So, can you use different dehumidifiers in conjunction with each other? The answer to that's yes, as long as you control your atmosphere. We talked a little about having heating and cooling that keeps your temperature between 70 and 90 if you're going to run LGRs. If you're going to do a mold job, you need to keep your temperature really cool so you keep your people under that OSHA guidelines that OSHA has for keeping your people safe. If it's cold in the building, your building materials are not going to give off moisture very fast at all, if any at all. The bound water is not going to want to come out if the wall surface is cold. Be sort of like drying your hair with their hair dryer with no heat on it. It's just going to take a lot longer to dry. So you may have to heat the building up to do that. You may need extra heat. So at some points in time, you can use any and all of these together. You've just got to figure out what your conditions are in the building and then put your conditions, where they need to be put at. So again, when you choose deskants, use the right deskant for the job. You've got all electric deskants that you may need in some areas. And we did a job for Coors in Golden, Colorado, and they didn't want any propane. They didn't want any diesel on site. They wanted all electric deskants, and they hooked them up to their power grid, and we ran all electric there. So sometimes you want to use diesel. We use those more than anything because low power consumption, easier setup, and we can get diesel fuel pretty much anywhere. Get different size deskants. The most common are anywhere from 5,000 to 10,000 CFM. 5,000s are probably more common, but there are several 10,000 CFMs out there, and then you'll find a few bigger than that. But the little bit of difficulty with the really large units, such as like a 25,000 CFM, is it's a lot of air to push through one doorway or one window on one end of the building. Usually, if you need that much air, you'd like to scatter those around the building so you got different entry and exit points into the building. So, propane can be a little bit difficult to get during the winter. The propane trucks are busy. During the summer, they've laid all the propane truck drivers off because they're not busy. So sometimes propane can be a little bit of a challenge. So set an account up with a propane company in your area. See if U-Haul fills up tanks for you, and then you have to have a way to transport them. And you got to consider some DOT laws when hauling propane. We're not going to go over that today, but if anybody has a question on it, feel free to give me a call about it. This is a 9,000 CFM all electric unit. The heaters in it run on all electricity. It takes a very large generator to run it, usually somewhere close to 200 kW to run it, and she will suck some fuel, about 8 to 9 gallons an hour. They do have their advantages. If you have problems getting diesel, still got to have it for the generator, but sometimes they come in handy for the all electric part on it. And it's a cargo carrier unit, very good machine. And it, sometimes you want all electric for whatever reason that you have. This is the same unit seen in the other picture. It's dual fired. It'll run on either propane or electricity, either one. If you're on all electricity, you're going to need 150 to 175 kW. If you're running on propane, you can run it on a 45 kW because then your propane is producing the heat for it. Some more units that are going to the paint shop. Just coming back off of a hurricane, so you can see the propane tanks on there and a couple of the units fastened up there, and stuff looks like it's pretty much ready to go back to the paint shop and get painted after a rough winter at the hurricane. The truck's actually illegal. It's illegal to put 2 propane bottles on one truck, but maybe they didn't get caught. Low amps when you're running on propane. Again, you can run on low amperage on your equipment. If you're running propane, if you turn them to all electric, you'll need to have a little bit more. This is a diesel fired unit. This unit was made by CDT. The burner on it is fueled by diesel fuel, so very low power demands, the most efficient machine on the market as far as fuel consumption. So we use those a lot. Diesel fuel is easy to get. Put a 100-gallon diesel tank on the back of your truck and run to the store once a day, and you're in good shape with it. So it makes it really easy to get. If you're bidding jobs, you can bid your job for the desiccant part of it, maybe up to 40% cheaper because you're using a lot smaller generator. Now, we do charge extra for the diesel burner unit on the billing of about $350 a day extra for it, but it's still cheaper than the generator and the fuel that would use. You need to make sure to put that in your notes on your billing so they can see why how you're using a unit that is a lot more fuel efficient and how that saves them money in the end. So I hope this has been helpful. You've got my number. You got my name. If you don't, holler at me and I'll get it to you. But, if you need anything with that, I'm Scott Tarpley. Just give me a call. Thank you. Bye.